North Atlantic, March 19th, 1943. Korvettenkapitän Klaus Hartmann stood in the conning tower of U-221, tracking convoy SC-122 through his periscope. 48 merchant ships, 8 escorts. The mathematics were clear. His Wolfpack had 12 boats. They would attack after sunset, overwhelm the screen, and disappear before dawn. Standard doctrine. He'd done it 9 times before. Then HMS Vanek appeared on his scope. Range 4,000 meters, closing fast. Hartmann gave the order to dive. U-221 slipped beneath the surface at 45 meters. Silent running, the destroyer passed overhead. Hartmann heard the familiar sound of depth charges rolling off the stern. He braced for the explosions behind them, but the explosions came from ahead. 24 detonations in rapid succession, not behind the submarine where depth charges should fall. Ahead, precisely where U-221 was traveling, the boat shuddered. Cork insulation rained from the overhead. The forward torpedo room reported flooding. Hartmann ordered emergency surface procedures, but U-221's bowplanes wouldn't respond. They surfaced stern first, wallowing, helpless. HMS Vanek's guns opened fire. Hartmann gave the order to abandon ship. As he climbed onto the deck, water rushing past his knees, he saw something on Vanek's foredeck. A mortar system, barrels angled forward. Still smoking. That shouldn't exist. Depth charges fell behind attacking ships. Physics demanded it. You couldn't throw explosives forward while maintaining sonar contact. The propeller noise, the turbulence, the explosions themselves, all blinded underwater detection. Every submariner knew this. It was the fundamental tactical advantage that made evasion possible. But HMS Vanek had just done the impossible. It had thrown projectiles forward, maintained sonar contact, and placed 24 explosives, exactly where U-221 was going. Hartmann treaded water, watching his boat slip beneath the waves. He had 48 hours of combat ahead of him before the pattern would become undeniable. 48 hours before 8 U-boats would be destroyed, not by superior numbers or better seamanship, but by a weapon system that rewrote the physics of underwater warfare. March 1943 marked the beginning of the end for the Wolfpack. The Allies had deployed Hedgehog mortars across the escort fleet. German Naval Command didn't understand what had changed. Hartmann was about to receive a comprehensive education in forward-throwing weapons. The tuition would be paid in submarines and the lives of 400 men. In early 1943, the Battle of the Atlantic hung in balance. Admiral Dönitz commanded 411 operational U-boats. The Wolfpack doctrine was working. Coordinate by radio, mass against convoys, attack from multiple directions simultaneously. The escorts couldn't defend everywhere at once. February 1943 had been particularly successful. 63 Allied ships sunk, 365,000 tons sent to the bottom. British food reserves had dropped to 8 weeks, fuel reserves to 12 weeks. The mathematics favoured Germany. A few more months of this rate, and Britain would be forced to negotiate. If you're enjoying this deep dive into this story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But the Allies had developed something new. Not radar this time, not direction finding or code breaking, something more fundamental. They had solved the basic tactical problem of anti-submarine warfare. Until March 1943, attacking a submerged U-boat meant choosing between maintaining sonar contact or delivering weapons. Conventional depth charges rolled off the stern. The attacking ship had to pass directly over the submarine's position. But passing overhead meant 3 things. First, the ship's propeller noise drowned out sonar returns. Second, the turbulence from the propeller scattered sonar waves. Third, the attacking ship was moving away from the target by the time depth charges exploded. The result was predictable. Escort ships lost sonar contact during the final approach. Depth charges fell based on the submarine's last known position, not its current position. A U-boat captain who altered course or depth after the escort lost contact could evade. The statistics proved it. In 1942, British escorts had achieved only a 6% kill rate per attack, 16 attacks required on average to destroy one U-boat. The escorts couldn't sustain that rate. They had to stay with convoys. They couldn't hunt individual contacts for hours. U-boat captains understood this tactical advantage intimately. When an escort gained sonar contact, standard procedure was to change course by 30 degrees, change depth by 20 meters, go silent. The escort would pass overhead, drop charges, lose contact. By the time sonar cleared, the U-boat was somewhere else. A box, 2 kilometers on each side, too large to search effectively while the convoy steamed away at 7 knots. Hartmann had evaded 14 depth charge attacks using this method. His crew trusted it absolutely. Change course, change depth, wait for the escort to pass, then surface after dark, recharge batteries, reposition for attack. The cycle repeated until either the convoy escaped or the Wolfpack achieved coordination for a mass attack. But Hedgehog changed everything. The weapon system had been developed by the British Directorate of Miscellaneous Weapons Development in 1941. The concept was simple. Instead of rolling depth charges off the stern, throw projectiles forward from the bow. Multiple projectiles, in a pattern, while maintaining sonar contact throughout the approach. The engineering was complex. Each Hedgehog installation consisted of 24 spigot mortars arranged in 4 rows of 6. Each spigot held a projectile, 7 inches in diameter, 65 pounds total weight, 35 pounds of Torpex explosive, far less than the 300 pounds in a conventional depth charge. But Hedgehog didn't need the massive explosive charge because Hedgehog projectiles used contact fuses, not depth fuses. A depth charge detonated at a preset depth, typically set to the submarine's estimated depth. The explosion created a pressure wave. If the submarine was within 20 feet of the explosion, the pressure wave could crack the hull. But 20 feet was a small target in 3-dimensional space. Miss by 30 feet, and the submarine survived. Miss by 50 feet, and the crew barely noticed. Hedgehog projectiles only detonated on direct contact with the submarine hull. A hit meant a 35-pound shaped charge exploding against steel plate at point-blank range. No U-boat could withstand that. The contact fuse also meant that if the projectiles missed, they sank to the ocean floor without exploding. This was crucial. Conventional depth charges exploded whether they hit or not. The explosions created massive turbulence, obliterated sonar returns, and forced the attacking ship to break contact, reacquire the target, and attack again. The process took 20 to 30 minutes, long enough for a U-boat to escape. Hedgehog projectiles that missed made no sound. Sonar contact remained clear. The escort could adjust course and fire again within 2 minutes. The attacking ship could make multiple attacks in rapid succession, each one more accurate than the last, because the submarine's position was known continuously. The firing pattern was calculated mathematically. When fired, all 24 projectiles launched simultaneously. They arced through the air, splashed into the water 200 meters ahead of the attacking ship, and sank in an elliptical pattern. The ellipse measured 40 meters wide by 30 meters long. It covered the probable area where the submarine would be by the time the projectiles descended to target depth. The projectiles sank at 23 feet per second. A submarine at 150 feet depth meant 6.5 seconds of sink time. During those 6.5 seconds, the escort maintained perfect sonar contact. If the submarine changed course or depth, the escort operator saw it immediately and corrected the approach for the next salvo. The first Hedgehog systems were installed on British escorts in January 1943. By March, 42 Royal Navy vessels carried the weapon. By May, the number reached 108. The Americans adopted it immediately. By June 1943, every new destroyer escort coming out of American shipyards carried Hedgehog as the standard equipment. But in March 1943, the Germans didn't know any of this. They knew escorts were becoming more effective. They knew attack survival rates were declining. but they attributed it to better training, improved radar, increased air cover. They didn't understand that the fundamental physics of depth charge attacks had been made obsolete. Hartmann was retrieved from the Atlantic by HMS Vanek at 0900 hours, March 19th. 42 survivors out of U2-1's crew of 48. They were taken below decks, given dry clothes and hot food, standard treatment under the Geneva Convention. While Hartmann dried off, HMS Vanek rejoined the convoy escort screen. The other U-boats in Wolfpack Raubgraf continued their approach. U-384, commanded by Captain Lieutenant Hans-Achim von Rosenberg-Gruszczynski, had been tracking SC-122 for 6 hours. His position was optimal. Ahead of the convoy, submerged at periscope depth, waiting for nightfall. At 1400 hours, HMS Harvester gained sonar contact, range 1200 meters. Closing. Von Rosenberg ordered standard evasion. 30 degrees to port, depth to 65 meters. Silent running. Crew to diving stations, electric motors to dead slow. They waited. HMS Harvester's sonar operator held contact. The target had altered course, left, and gone deeper, but the Type 144 sonar tracked it clearly. The range closed. 1,000 meters. 800. 600. The Hedgehog crew stood ready. Lieutenant Commander Alan Rodney commanded HMS Harvester. He'd practiced Hedgehog attacks for 3 weeks before this patrol. He knew the system's capabilities and limitations. Maximum effective range, 400 meters. Optimal firing range, 250 meters. The sonar picture had to be clear. No thermalines, no turbulence, no multiple contacts. At 300 meters range, Rodney gave the order. Fire Hedgehog. The pneumatic system launched all 24 projectiles in 0.8 seconds. The sound was distinctive. A rapid series of hollow thumps, nothing like the heavy splash of depth charges. The projectiles arced forward, splashed in their elliptical pattern, and sank. HMS Harvester maintained course and speed. The sonar operator maintained contact. U-384 was at 65 meters depth, speed 3 knots, course 200 degrees, 6.2 seconds after launch, 5 detonations. The sonar screen showed the target bloom, then collapse. Debris began rising, oil slick spreading. HMS Harvester circled the area, wreckage surfaced, wooden planking, life jackets, a floating boot. No survivors. U-384 destroyed. Time from initial contact to confirmed kill, 14 minutes. Von Rosenberg never knew what hit him. The standard evasion procedures that had worked 17 times before had failed completely. At 1600 hours, U-1665, commanded by Oberleutnant Zursee, Hans-Jürgen Haupt, detected SC-122's escort screen. He began his approach, submerged. At 1720 hours, HMS Swale gained sonar contact. Haupt executed standard evasion. Change course, change depth, go silent. HMS Swale held contact. At 1734, Hedgehog fired. 4 detonations. U-665 destroyed. 19 minutes from detection to kill. Aboard U-621. Captain Lieutenant Max Kruschka monitored radio traffic. Standard procedure was for U-boats to report contact, report attacks, report results. U-384 had reported escort contact at 1400 hours. No further transmission. U-665 had reported beginning attack approach at 1645. No further transmission. 2 boats. Radio silence after escort contact. This was concerning, but not unprecedented. Radio silence could mean the boats were evading, conserving battery power, maintaining stealth, or it could mean they were dead. Kruschka continued his approach. At 1800 hours, with dusk approaching, he prepared to surface and move to attack position. At 1830, HMS Vedette gained sonar contact at 1,400 meters. Kruschka dove to 80 meters. Standard evasion. HMS Vedette closed to 300 meters. At 1846, Hedgehog fired. 6 detonations. U-621 destroyed. No survivors. March 19th, 2200 hours. Convoy SC-122 had been under Wolfpack attack for 18 hours. Wolfpack Raubgraf consisted of 12 boats. 4 boats were now confirmed destroyed. 8 boats remained operational. But those 8 boats couldn't establish radio contact with the 4 missing boats. The pattern was becoming clear to the surviving commanders. Every boat that made contact with escorts was going silent, not damaged, not evading, silent, permanently. Aboard U-527, Korvettenkapitän Herbert Uhlig was the senior commander of Wolfpack Raubgraf after Hartmann's capture. He studied the tactical picture. 4 boats missing in 8 hours, all after escort contact, all without time to report detailed combat results. Conventional depth charge attacks took time. A U-boat under depth charge attack could usually report its situation, send a brief transmission, escort attacking, evading. The transmission took 6 seconds. Even under heavy attack, 6 seconds was possible. But these 4 boats had gone silent instantly. Contact reported, then nothing. Uhlig considered the possibilities: new explosive, deeper depth charges, better sonar, more escorts than intelligence indicated. None of these explanations fit. Something fundamental had changed. Something about the attack method itself. At 2300 hours, Uhlig's watch officer reported a radar contact. Destroyer, range 6 kilometers, closing. U-527 was on the surface, charging batteries. Uhlig dove immediately. The destroyer was HMS Loosestrife. It had detected U-527's surface radar emissions using its Huff-Duff equipment. HMS Loosestrife altered course to intercept. At 2340, its sonar gained contact, range 1,000 meters. Uhlig executed a different evasion pattern. Instead of going deeper and turning 30 degrees, he went shallow and turned 90 degrees. Sharp turn, shallow depth, silent running. HMS Loosestrife's sonar operator watched the target turn hard left and rise to 40 meters. He reported continuously to the captain. Target turning port, now bearing 270, depth 40 meters, speed 2 knots. At 2351, HMS Loosestrife fired Hedgehog. The elliptical pattern splashed ahead. U-527 detected the sound, not the heavy splash of depth charges, multiple smaller splashes forward of the attacking ship. Uhlig understood instantly. The escorts had forward-throwing weapons. That changed everything. He ordered emergency deep, flood, negative tank, full dive on planes. U-527's bow pitched downward. The deck tilted 15 degrees. Men grabbed handholds. The depth gauge spun, faced 40 meters, 50, 60. The Hedgehog projectiles reached 40 meters and found nothing. They continued, sinking silently. U-527 reached 90 meters and leveled off. HMS Loosestrife's sonar operator called out. Target went deep. Depth now 90 meters, bearing 265. Speed 4 knots. The captain adjusted course and speed. At 0008, March 20th, HMS Loosestrife fired Hedgehog again. The projectiles sank to 90 meters, 7 detonations. U-527 destroyed. Uhlig's evasion had bought him 17 minutes, but the forward-throwing weapons didn't care about evasion patterns. As long as sonar contact held, the escorts could adjust, fire again, adjust, fire again. The cycle continued until projectiles found their target. March 20th, 0200 hours. 48 hours since the convoy battle began. Wolfpack Raubgraf had started with 12 boats. 5 were confirmed destroyed, 7 remained. But the 7 surviving commanders were beginning to understand what they faced. The radio traffic told the story. U-616 reported at 0230. Escort contact, diving, evading. No further transmission. HMS Woodpecker gained sonar contact at 0235. Hedgehog attack at 0251. 4 detonations. U-616 destroyed. U-435 reported at 0300. Multiple escorts. Heavy contact. Breaking off. HMS Vervain and HMS Narcissus coordinated. Both ships held sonar contact. HMS Vervain attacked with Hedgehog at 0320. Miss. HMS Narcissus attacked at 0323. 5 detonations. U-435 destroyed. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. March 20th, 0400 hours. Wolfpack Raubgraf now had 5 boats operational, 7 destroyed in 24 hours. The remaining commanders knew the mathematics were impossible. 7 boats destroyed meant roughly 350 men dead, 0 merchant ships sunk. The Wolfpack had achieved nothing except its own destruction. Aboard U-415, Captain Lieutenant Kurt Neider made a decision that would save his boat. He broke standing orders. At 0430 hours, he surfaced 12 kilometers from the convoy and transmitted a detailed report to U-Boat Command. Not the standard brief contact report, a full tactical analysis. 7 boats destroyed in 24 hours. All after escort contact, all destroyed during submerged evasion. Escorts possess forward-throwing weapons, multiple projectiles, elliptical pattern, contact fuses. Attacking ships maintain continuous sonar contact throughout attack. Standard evasion procedures ineffective. Recommend immediate tactical revision. NAID. The transmission took 42 seconds, long enough for Allied direction-finding stations to get a bearing. But NAID calculated the risk was worth it. 7 boats destroyed meant U-Boat Command needed to understand what was happening. The reply came 90 minutes later from Admiral Donit's headquarters in Paris. Report received. Confirm forward-throwing weapons. Technical intelligence analyzing. All boats implement maximum evasion depth. Exceed rated limits if necessary. Break contact at any cost. Donitz. Maximum evasion depth. That was the key insight. German Type 7 U-boats were rated for 180 meters maximum depth. Crush depth, where the pressure hull would fail, was estimated at 220 to 250 meters, depending on hull condition and manufacturing quality. German doctrine specified never exceeding 200 meters, except in absolute emergency. But if the escorts had forward-throwing weapons that could attack while maintaining sonar contact, then staying at conventional depths meant death. Better to risk hull collapse than face certain destruction. The remaining Wolfpack commanders understood immediately. At 0600 hours, March 20th, U-168, commanded by Oberleutnant zur See Helmut Pick, made contact with the convoy's northern escort screen. HMS Anemone gained sonar contact within 3 minutes. Pick dove immediately, but instead of leveling at 60 or 80 meters, he took U-168 to 210 meters. The pressure hull groaned, rivets creaked, small leaks appeared around pipe fittings. The crew watched the depth gauge with terror. The needle was past the red line. They were below crush depth, but HMS Anemone's Type 144 sonar had difficulty tracking targets below 180 meters. The sonar beam became less focused at extreme depth. Returns became fuzzy. At 210 meters, HMS Anemone lost solid contact. The Hedgehog system required precise target data, depth within 5 meters, bearing within 2 degrees, speed within 1 knot. Without solid sonar contact, the fire control solution became guesswork. HMS Anemone made 2 Hedgehog attacks based on estimated position. Both missed. After 30 minutes, HMS Anemone broke off the hunt and returned to the convoy. It couldn't leave the merchant ships unprotected for extended pursuit. U-168 remained at 210 meters for another hour, then slowly, carefully, rose to 100 meters. The pressure eased. The hull stopped groaning. Small leaks could be patched. Peach had survived by exceeding design limits, but this tactic had costs. Staying at extreme depth drained batteries rapidly. The electric motors had to work harder to maintain depth control. The pumps had to run continuously to handle leaks. A boat at 200 meters could only stay submerged half as long as a boat at 60 meters, and rising from extreme depth took time. 15 to 20 minutes of slow ascent to avoid hull stress. During that ascent, the U-boat was vulnerable, slow, and predictable. The escorts learned this quickly. When a U-boat went deep and disappeared from sonar, the escorts didn't pursue. They waited. They knew the boat would have to surface eventually. When it did, they would be ready. March 20th, 1400 hours. Convoy SC-122 had been under attack for 30 hours. 8 U-boats destroyed. 4 boats remaining operational. 0 merchant ships sunk. The mathematics were final. Wolfpack, WWII had achieved nothing except its own destruction. At 1500 hours, Admiral Donitz transmitted new orders. All WWII boats break contact. Withdraw to grid square AM-72. Regroup for analysis. It was an admission of defeat. For the first time in the Atlantic campaign, a Wolfpack was withdrawing without achieving tactical success, without sinking a single ship. But the escorts weren't finished. HMS Pennyworth detected U-529 during its withdrawal. Captain Lieutenant Georg Fratz tried the deep evasion tactic. He took U-529 to 220 meters. HMS Pennyworth lost solid sonar contact, but maintained approximate bearing. The destroyer waited. 30 minutes. 40. At 53 minutes, U-529's batteries were critically low. Fratz had to surface or risk losing all power and sinking uncontrolled. He began a slow ascent. At 180 meters, HMS Pennyworth regained solid sonar contact. At 120 meters, Hedgehog fired. The projectiles sank directly into U-529's ascent path. 8 detonations. The boat was rising slowly, predictably, unable to maneuver. U-529 destroyed. No survivors. March 21st, 0800 hours, 72 hours since the Convoy battle began. 9 U-boats destroyed. 3 boats successfully withdrew. Convoy SC-122 had lost 0 ships to U-boat attack. 1 merchant vessel had straggled and been sunk by U-338 operating independently, not part of WWII. But the Wolfpack itself had failed completely. The surviving commanders reached the regrouping point in grid square AM-72, 300 kilometers southwest of Iceland. U-415, U-441, and U-168. 3 boats out of 12. 75% casualties. The commanders surfaced and met aboard U-415. This was highly irregular. U-boats rarely surfaced together. The risk of a single air attack destroying multiple boats was too high. But Nide insisted. They needed to understand what had happened. The 3 captains sat in U-415's cramped wardroom. Nade, Captain Lieutenant Klaus Hartenstein of U-441, and Peak of U-168. They compared notes. Nade spoke first. Forward-throwing weapons. I saw the splash pattern during my first attack, 20 or more projectiles. They landed ahead of the escort, not behind. Elliptical pattern, approximately 40 meters wide. Hartenstein added his observation. Contact fuses. When the projectiles miss, there's no explosion. Conventional depth charges explode whether they hit or not. These only explode on contact, which means the escorts maintain sonar contact throughout. They can fire again immediately. Peach described his deep evasion. It worked, but barely. At 210 meters, my hull was leaking in 6 places. We can't sustain that depth for long, and surfacing takes 20 minutes. We're vulnerable the entire time. Nade pulled out a chart and marked every U-boat loss. U-221, U-384, U-665, U-621, U-527, U-616, U-435, U-432, U-529. 9 boats. He calculated the timeline. Most boats survived less than 20 minutes after initial escort contact, some less than 15. The average depth charge attack took 40 to 60 minutes. Multiple attack runs. Time for the U-boat to evade between runs. But these new weapons compressed the timeline. 1 attack run. 1 pattern. If it hit, you died. If it missed, the escort fired again within 2 minutes. Hartenstein voiced what they were all thinking. We can't fight this. Not with current tactics. The entire Wolfpack doctrine depends on coordination. But coordination means radio transmissions. Transmissions mean direction finding. Detection means escort contact. And escort contact means death. The cycle is complete. Nade nodded slowly. We're not fighting destroyers anymore. We're fighting a system. Radar detects us on the surface. Direction finding locates our transmissions. Sonar tracks us underwater. And these new weapons kill us before we can evade. Peach added the final piece. And they're fast. The production rate must be enormous if every escort has these weapons. We encountered 6 different escorts. All of them had forward-throwing capability. That means dozens of ships, probably hundreds across the entire Atlantic. The Allies had industrialized anti-submarine warfare. It wasn't individual ship commanders or tactical brilliance. It was mass production of effective weapons integrated into a comprehensive system. The 3 commanders transmitted their joint report to U-boat command. Then they dove and began the long journey back to base at Lorient, France. They maintained complete radio silence. They dove at the first hint of aircraft. They avoided all convoy routes. All 3 boats made it home. They arrived between March 25th and March 27th, 1943, at Lorient. The surviving crews were debriefed extensively. Technical intelligence officers recorded every detail about the forward-throwing weapons, the splash patterns, the timing, the sonar contact maintenance, the attack profiles. German naval engineers analyzed the information and reached a conclusion. The British had developed a multi-projectile forward-throwing mortar with contact fuses. The system allowed escorts to attack while maintaining continuous sonar contact. It was devastatingly effective. But understanding the weapon didn't provide a counter. The technical solution was obvious: go deeper than the escort's sonar could track reliably. But U-boats couldn't stay at extreme depth long enough to escape. The tactical solution was equally obvious: avoid escort contact entirely. But that meant avoiding convoys, which meant the U-boats couldn't sink merchant ships, which meant they couldn't win the Battle of the Atlantic. Admiral Dönitz faced an impossible situation. He had 400 operational U-boats, but if every escort encounter resulted in U-boat destruction, then those 400 boats would be gone within months. The mathematics were brutal. March 1943 saw 9 U-boats destroyed in one convoy battle. Multiply that across the entire Atlantic, across all convoy routes, against all escort groups. The loss rate was unsustainable. Dönitz ordered a comprehensive tactical review. New procedures were drafted. Avoid prolonged submerged operations near escorts. Break contact immediately if detected. Never attempt to attack a convoy with active escort screen. Wait for stragglers. Attack isolated targets only. The new procedures were defensive. They acknowledged that U-boats could no longer fight escorts on equal terms. But even defensive procedures couldn't save the Atlantic campaign. April 1943 saw 41 U-boats destroyed. May 1943 saw 43 destroyed. Black May, the U-boat crews called it. 1/4 of the operational fleet sunk in 30 days. On May 24th, 1943, Dönitz ordered all U-boats to withdraw from the North Atlantic convoy routes. It was an admission of defeat. The weapon that changed everything was called Hedgehog. The name came from the visual appearance of the 24 spigot mortars bristling from the foredeck. British sailors thought it looked like a hedgehog's spines. The weapon had been invented by Lieutenant Commander Charles Goodeve of the Royal Navy Volunteer Reserve. He wasn't a career naval officer. He was a chemistry professor at the University of London who volunteered for military service in 1939. Goodeve worked at the Directorate of Miscellaneous Weapons Development, a small research group tasked with solving tactical problems the main naval establishment considered insoluble. The depth charge problem was well known. Attacking ships lost sonar contact during the final approach. Goodeve proposed a simple solution: don't attack from behind. Attack from the front, throw weapons forward while maintaining sonar contact. The engineering challenges were significant. Forward throwing meant the projectiles had to be launched at a precise angle and velocity to land in a pattern ahead of the moving ship. The pattern had to cover the target area where the submarine would be several seconds in the future. The projectiles had to be small enough to launch in quantity but powerful enough to destroy a U-boat on contact. Goodeve worked with William Butemont, a physicist, and John Harding, an engineer. Together, they designed the spigot mortar system. Each projectile sat on a steel rod. When fired, a small gunpowder charge in the base of the projectile generated gas pressure. The pressure pushed the projectile off the spigot and into the air. The spigot acted as a launch rail. ensuring consistent trajectory. The mathematics of the firing pattern took months to perfect. The projectiles had to land in an ellipse because submarines moved forward. By the time projectiles landed and sank to target depth, the submarine had traveled forward. The ellipse compensated for that movement. The contact fuses were equally critical. Conventional depth fuses detonated based on water pressure at a preset depth, but water pressure measurement wasn't precise enough. Miss by 10 meters, and the explosion was ineffective. Contact fuses solved this by requiring direct impact. The fuse consisted of a simple mechanical trigger in the projectile's nose. On contact with any solid object, a spring-loaded firing pin struck a detonator. The detonator initiated the main Torpex charge. Impact to detonation took 30 milliseconds. The first Hedgehog prototype was tested in November 1941. The tests were successful. By January 1942, production began. By March 1943, 42 Royal Navy escorts carried Hedgehog. By June, 108. By December 1943, 270. The Americans adopted the design immediately and began production at the Leavitt shipyard in Massachusetts. By May 1943, every new American destroyer escort carried Hedgehog as standard equipment. The kill statistics told the story. In 1942, British escorts achieved a 6% kill rate per attack using conventional depth charges. In the second half of 1943, after Hedgehog deployment, the kill rate rose to 25% per attack, a fourfold improvement. Even more significantly, the time required per kill dropped from 45 minutes average to 18 minutes. Escorts could destroy U-boats faster and return to convoy protection duties sooner. The impact on U-boat operations was catastrophic. In the first quarter of 1943, U-boats sank 195 Allied ships. In the fourth quarter of 1943, they sank 58. The reduction was 70%. Meanwhile, Allied merchant ship construction accelerated. American shipyards were launching a new Liberty ship every 42 hours. British yards produced escorts faster than U-boats could sink them. The mathematics that had terrified Churchill in 1942 reversed completely. By late 1943, the Allies were gaining ships faster than Germany could sink them. The convoy system became unbreakable. Klaus Hartmann survived the war. After his capture in March 1943, he spent 2 years in a Canadian prisoner of war camp. He was repatriated to Germany in 1945. In interviews conducted in the 1980s, Hartmann spoke candidly about the Hedgehog weapon. "We knew something had changed," he said, "but we didn't understand the full system until after the war. The Hedgehog was just one piece. They had radar that detected us on the surface, direction finding that located our transmissions, improved sonar that tracked us underwater, and Hedgehog to kill us efficiently. Each technology was effective alone. Together, they created a system we couldn't counter." Hartmann was asked if better U-boat technology could have made a difference. More advanced submarines, better torpedoes, longer range. He shook his head. Technology wasn't the deciding factor. The Allies built a system. We built individual weapons. They coordinated radar, sonar, aircraft, and surface ships into an integrated network. We sent submarines out individually to hunt convoys. They used multiple technologies working together to hunt us. The fundamental approach was different. They thought systematically. We thought tactically. Kurt Neider also survived. He commanded U-415 until October 1943, when it was sunk by Allied aircraft. Nade and 18 crew members survived and were captured. After the war, he wrote technical analyses of anti-submarine warfare for the new German Navy. His conclusion echoed Hartmann's observation. The Battle of the Atlantic was lost because we couldn't adapt fast enough. By the time we understood Hedgehog, the Allies had deployed it across the entire escort fleet. By the time we developed counter-tactics, they had integrated Hedgehog with other systems. We were always reacting, never anticipating. The industrial capacity difference made it impossible to catch up. Helmut Peak of U-168 did not survive the war. His boat was sunk in October 1943 by Dutch submarine H&M Zwaardvis in the Java Sea, there were no survivors. The Hedgehog system remained in service with various navies until the 1980s. The United States Navy used it through the 1970s. The basic principle of forward-throwing weapons influenced all subsequent anti-submarine systems. Modern navies use rocket-propelled torpedoes launched from vertical tubes. The torpedoes fly through the air, enter the water ahead of the attacking ship, and guide themselves to the target using active sonar. The principle is identical to Hedgehog: attack from ahead while maintaining contact. But the technology that defeated Germany in the Battle of the Atlantic wasn't just Hedgehog. It was the integration of multiple systems into a coordinated whole. Centimetric radar detected surface U-boats at 30 kilometers. High-frequency direction finding located radio transmissions within 5 kilometers. Improved sonar tracked submerged contacts to 200 meters. Depth. Hedgehog killed targets in one attack run. Escort carriers provided air cover in mid-ocean. Ultra-intelligence from broken Enigma codes gave strategic warning. Each system fed information to the next. Radar narrowed the search area. Direction finding pinpointed the location. Sonar tracked the dive. Hedgehog delivered the kill. The German response was fragmented. They improved U-boat technology incrementally. Faster submarines, better torpedoes, snorkel breathing tubes. But they never created an integrated defensive system. They never coordinated their technologies into a unified counter-strategy. By late 1943, the outcome was inevitable. Germany couldn't build U-boats faster than the Allies could sink them. More importantly, Germany couldn't train experienced crews faster than the Allies could kill them. A U-boat commander required 2 years of training and multiple patrols to become effective. By 1944, the average U-boat crew had 6 weeks of training and 0 combat experience. They were sailing into the Atlantic against escorts with Hedgehog, centimetric radar, and experienced crews. The result was massacre. Of the 39,000 men who served in German U-boats during World War II, 28,000 died, a casualty rate of 72%, the highest of any military service in any nation during the war. Most died in 1943 and 1944 after the Allies deployed Hedgehog and integrated their detection systems. The lesson of the Battle of the Atlantic extends beyond naval warfare. Technology wins battles, but integrated systems win wars. Individual weapons, no matter how advanced, cannot overcome a coordinated system of mutually supporting technologies. Germany built excellent submarines. Britain built an excellent anti-submarine system. The system defeated the submarines because the system could adapt, coordinate, and concentrate force more effectively than individual platforms operating independently. This principle applies to every major conflict since 1943. Vietnam, the Falklands, the Gulf Wars, Afghanistan. The side with superior system integration usually wins, regardless of individual weapon superiority. The Battle of the Atlantic was decided by mathematics, by production rates and casualty ratios, by detection ranges and attack cycles, and by a forward-throwing mortar system called Hedgehog that could place 24 contact-fused projectiles precisely where a U-boat would be 6 seconds in the future. Wolfpack, Graf lost 9 boats in 72 hours because they fought individually against a system. Coordination through radio became a death sentence. Evasion tactics became ineffective. And the fundamental advantage that made U-boats dangerous, their ability to hide in the vastness of the Atlantic, disappeared when the Allies could detect them continuously from initial contact to final destruction. The invisible technology that sank 8 boats in one convoy was Hedgehog. But the invisible victory was systematic integration, building not just better weapons, but better coordination between all weapons. That integration changed the Battle of the Atlantic from a German advantage to an Allied victory, and it changed the outcome of World War II. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.